Good morning, everyone. Today we're going to take multiplying polynomials special cases to a little bit different of a level. So last session you were working on raising a binomial to the power of 2. Today we're going to see what happens when we raise the binomial to a power of 3. So just like before, we cannot just cube each individual term. We really need to write the binomial 3 times because our exponent is a 3. So we're going to have 2x plus 3 times 2x plus 3 times 2x plus 3. So when we go ahead to try and do this, you might be asking yourself, what am I going to do now? There's 3 binomials. Well, we're going to work very similarly to that we did last time, except for that we're going to box it off. We're going to section it off and work with 2 binomials first, and then the last binomial afterward. So I'm going to put a square bracket around the first set of binomials. And then I'm going to pretend that this part doesn't exist here, and I'm going to work with just multiplying these like we did before. So in my first bracket, I'm going to have 2x times 2x plus 3, and then plus 3 times 2x plus 3. Close the bracket, and I'm going to bring this down here just so that I don't forget about it. A lot of times people forget about it. We don't want to do that. So now when we go ahead, we're going to distribute. So we get 4x squared plus 6x plus 6x plus 9, and then our 2x plus 3. So again, that's going to come down. And now we're going to simplify. So we get 4x squared plus 12x plus 9. I can change that back to a regular parenthesis, and then 2x plus 3. And now we can multiply this trinomial by this binomial using the same methods that we did before. So we can take our 4x squared and multiply it by the 2x plus 3. And we can take the 12x and multiply it by the 2x plus 3. And we can take the 9 and multiply it by the 2x plus 3. So go ahead and distributing one step more. We have 8x cubed plus 12x squared plus 24x squared plus 36x plus 18x plus 27. So we have a lot of terms here. We're going to now simplify by combining our like terms. So if you remember, a like term has the same variable with the same exponent. So we have 2 like terms over here. We have another 2 right here. So if we combine these, and again, writing in standard form, the variable with the highest exponent comes first. We're going to add these 2 together to get 36x squared, and we're going to add these 2 together to get 54x, and then we're going to have our 27. And so we are finished with that. So you might be asking yourself, if we look back at this problem, why are we sectioning off the first 2? Could we section off the last 2? And the answer is yes. So I'm going to just show you that so that you can see you come out to have the exact same answer if you section it off differently. If you section it off differently by the last 2, you're going to work with the 2 binomials here first. And so you end up with your 2x times 2x plus 3 times 2x plus 3, simplifying all that down, and then you're going to multiply this binomial by this trinomial. And so you see here, you get exactly the same answer as you did before. And that is because multiplication is commutative. It doesn't matter whether you multiply the first 2 binomials first or the last 2 binomials first. You can switch the order and the answer will still be the same. So that's it for today, guys. Have a great day.